let's consider two simple examples. First, we have the vector C times the dyadics of vector A and B. So this thing, we can expand all of the vectors. This thing times EI, EJ, and we have AI, BJ. So if we pull the CK out, we will get EK encounters EI, right, with a dot product, and then we have EJ. And here we have all the constants, CK, AI, BJ. Okay, so what's EK dot EI? Kronecker delta. Delta KI, EJ, CK, AI, BJ. Only when what will we get a contribution from this thing? Only when k equals I, right? So we set k equals I, here k equals I, then we get delta II is equal to 1. So EJ, CIAI, BJ. We can say this is our final result. Well, let me ask you a question. What's this thing? What dimension? Let's first ask. What's the dimension of this thing? Well, we see that the I here appears twice, right? And the J here appears twice too. So we need to sum both of them. So we can say for I equals 1 to 3, for J equals 1 to 3, right? And we sum all the 9 terms. What do we end up with? Every term will be a vector, right? So the sum will also be a vector. So first we understand that this thing will give us a vector. The next question is, which direction will this vector give us? Well, let's still consider the loop, right? For the sake of simplicity, let's set the I to be the outer loop, okay? So for I equals 1, 2, 3, what will happen in the inner loop? We need to set a CIAI value, right? Let's say first we have C1A1. Okay, that thing is a constant. And here in the inner loop, we need to sum all the J's, right? So we have E1B1 plus E2B2 plus E3B3. What is this? It's just the B vector, right? It's just the B vector. So when I equals a certain value, then we have the B vectors inside. So what will be the final result of this? This vector will have the same direction as the B vector, right? This vector is basically C1A1 plus C2B2 plus C3B3 all in a brackets and times B vector. So this will be our result. Okay, now let's consider another example. Let's say we first have the dyadics, and then we have the dot product. Also, we can expand this thing. And this thing dot EK, CK. Okay, so same reasoning. AI and BI, we can put it at the back. Put it in the back. EI times EJ times EK. We can first compute the dot product. Okay. So here we have AI, BJ, CK. And here we'll have delta JK, right? EI, delta JK, and AI, BJ, CK. Only when K equals J will we get a contribution from this thing, right? So K equals J. Here K equals J, and we have EI, delta JJ, which is 1, AI, BJ, CJ, right? I appears twice, J appears twice. Again, this thing will give us a vector. So what's the direction? Well, now I think it's easier for us to first to set the outer loop to be the loop on J, right? For J equals 1 to 3, and here, when I goes from 1 to 3, what do we have? E1, A1 plus E2, A2 plus E3, A3. This is just the A vector, right? So every time when we set a J value, we will get a multiple of the A vector. So what do we end up with? A multiple of A vector, which is, to be exact, you can say it's B1C1 plus B2C2 plus B3C3, all in a brackets, and times the A vector. So here we end up with a vector which has the same direction as the A vector, right? You can compare this result with this result, where we have a vector which has the same direction as the B vector.